All right, well, good morning, calculus students. Um, it is 9:45 Sunday morning. Um, I imagine most of you are still asleep, but I've been up for several hours. Remember, the time fell back, so like my clock still says 10:45, but I'm pretty sure it's only 9:45. Anyways, I wanted to go ahead and get this recording posted. So if you want to get ahead of schedule for Tuesday, you are more than welcome. What you're going to be working on for our asynchronous day is a lab. Okay, you're going to be trying to discover rules for the derivative of different basic functions that you have learned from, you know, pre-algebra and algebra all the way up to pre-calculus. So I just want to go through the instructions and to get you started, and then you will obviously have whatever time you need to work on this. So the purpose here is to study the rates of change, like that's what calculus involves, studying the rates of change. So we're going to start by examining the rate of change of each of the elementary functions from pre-calculus. So if you think back to the exploration 3-1, where we discovered the derivative at a point and we calculated it by finding the limit of a difference quotient, okay? Essentially, that's what's going to be happening in this lab, but we're going to be using the calculator to find those difference quotients. So you won't actually be finding difference quotients. You won't even be seeing the calculator find those difference quotients. But what's going to happen is when you use Math 8 or NDeriv on your calculator, you're going to see that those values are plotted against the given x values, and then you're going to get a graph that approximates the rate of change function, which we call the derivative function. And so you're going to make note of those. You're going to be sketching graphs on your paper. So you want to make sure that you are neat and organized, because then you're going to be making conjectures or guesses about the equation for those derivative functions, and then you're going to test them out, and you're going to adjust until you can hopefully come really close, if not figure out exactly what the derivative of each of these functions are. So there are a few that you might not be able to come up with the exact equations, but please see how close that you can come. All right, so before we get into the lab and the graphing part and what you're going to be doing with that, all right, I want to kind of walk you through the first two that you really don't need a graph for. So like let's start with f of x equals k, right? K is just a constant. So this is like y equals 3 or y equals -10, all right? What does the graph of that sort of equation look like? Okay, like y equals 3. Well, I hope you remember that that makes a horizontal line. Okay, so then like think about how much do the y values change as the x values change. So if we have a, let's see if I can draw this. Whoa, all right. All right, so let's say that we have this coordinate plane and then we have a horizontal line. And let's say that we know that it goes through y equals 3. And I want to know how much do the y values change as I move along the x-axis. Well, if the y value is 3 the entire time, then the y value never changes, right? But the x values, they change all the time. So I'm just going to call that the change in x. All right, well, 0 divided by anything other than 0, right, is still 0. Okay? What is the rate of change then at each of these x values? Well, remember, the rate of change is just the same thing as the slope, all right, of that line. And the slope of a horizontal line is 0. So now we actually have a rule that if your function equals a constant, that's what k stands for here, then the derivative will always be 0. Okay? The derivative will always be 0. All right, let's look at another one that you don't really need to investigate a whole lot with a graph. All right, it says let f of x equal mx plus b. That's our standard linear function, y equals mx plus b. Well, what's the slope from that line? Right, well, I hope you remember that it's m, right? All right, well, what do we call the slope in calculus? Okay, well, slope is the same thing as rate of change, right? The slope is our rate of change, and rate of change is the same thing as derivative. So if the slope of all linear functions is its rate of change, then it is also its derivative. So if f of x equals mx plus b is your function, so if you have a linear function, all right, then the derivative of that linear function is just the slope. Okay, so real quick, just for an example, like if I had y equals 7x minus 21, and I asked you for y prime, okay, then literally the answer is just the slope. And hopefully if you look back at the problems you practiced with the formal definition, the limit definition, if you look back at the first couple where the function was either a constant, you should have gotten that the derivative was 0 no matter what. And if the original was a linear function, then your derivative should have been the slope of that linear function. All right, and so now let's get to the lab part. What are you going to be doing? Okay, so I'm going to kind of walk you through how to use your calculator real quick, and then kind of talk about what all you're going to be doing with this lab. So the lab starts with you letting f of x equal x squared, and you're going to type that function into your graphing calculator. So you're going to type it into y1, and you're going to sketch it on your paper. Okay, now in a minute it tells you to examine the graph of the derivative from -3 to 3. So if you want to you know, when you sketch the graph of the original, you don't have to go too far, you know, outside of that domain as your sketch. But you are going to have to sketch the original graph on your paper and label it as, you know, f of x equals x squared. Then what you're going to do is in y2, you're going to take the derivative of y1, all right, and so that we can graph it. So remember, to get the derivative in your calculator, you have to use math 8. And then remember, because you already have the function typed in y1, you can use alpha trace to find y1. And then, of course, you need to make sure you put x equals x right here so that it will graph the entire derivative. And then what you want to do is when you graph it, you actually want to turn off y1. And so you're going to move the cursor over to the equals and press enter, and it'll become unhighlighted. So let me run through that real quick on your calculator. Okay, so you're going to go to y equals. All right, and we're going to do x squared. And I always start with zoom 6 just to make sure I'm in a standard screen. And so you will want to sketch that on your paper. And you need to think about values that you actually know. Like when x equals 1 and you squared, you should get y equals 1. And when x equals 2, y equals 4. So like you want to make a nice sketch on your paper. When x equals 3, y equals 9. Okay, and so you want to, again, make a nice sketch. Then you're going to go to y equals, and you're going to arrow down to y2, and you're going to press math 8. You're going to do d over dx. That's the derivative with respect to x. Now, you can either type in x squared again, or this is where you can go to alpha trace and choose y1. And then in the next blank, you're going to have to do x equals x. And then we're going to arrow up, and we're going to arrow over to the equal sign and press enter. Okay, and when we move off of that equal sign, it should be unhighlighted. And all that's going to do is it's only going to graph y2, and it's not going to graph y1 anymore. So if I press graph, all right, there's my graph. okay? And you want to sketch that on your paper. Now, how can you get some nice points? Like, how can you know for sure where some of these points are? You can look at the table. So second graph takes you to the table, and you can see that when x equals 0, we're at the origin. When x equals 1, the value is 2. 2 is 4. 3 is 6. And you can actually go up and get, oh, I thought you could, oh, I know what I have. I probably have my table set to start at 0. So if you clear that out and then go back to table, oh, maybe not. All right, let's say we want to start at, I don't know, -10, just so you can get some negative values. You can go to table. I don't know why it's not going to -10. What am I not doing right? I wonder if I have it in ask mode. Hold on. Oh, I do. Okay. So let's go to auto. There you go. And then you actually could start it at 0, but it should let you go backwards. All right, so let's go back to my table. There we go. Okay, so you can move up and down to get some negative values. And then once you plot it, you're going to try to guess what the formula for that graph is, what the equation of that graph is. And then what you'll want to do is once you think you have a good guess, all right, you're going to type it in Y3 and graph it and see if it lines up with the graph that's already there. Okay? All right, so let me go back to the lab. All right, so it does give you some restrictions on, like, you can change your window a little bit, but you are going to draw a picture of the derivative graph next to your f of x graph on your paper. And make sure you label f of x equals x squared, and then the other one f prime of x equals, and then tell me what you think it equals. And don't write it, write it down once you think you have an accurate guess, right? So you're going to put your guess in Y3, and you're going to check your guess by graphing it on the same screen. And once you think you have figured out the correct formula, then you can tell me what f prime of x equals on your paper. You may want to use some graph paper if you have it available, just to keep things organized and make it easy to space everything out. All right, but that walks you through the process of what to do. And then when you get to number 4, you're going to be doing the exact same thing, but you're going to repeat that activity for x cubed, x to the 4th, 1 over x squared, sine of x, cosine of x, e to the x, and ln of x. Okay, so that's quite a few sketches you're going to be doing on your own paper. So you're going to sketch the original, and then you're going to sketch the graph of the derivative that the calculator gives you. Keep in mind when you do the trig functions, make sure that you're in radian mode. All right, and so you may want to go back and look at, like, remember there was a module of things you need to know, and they were trig graphs. So you might want to go back and look at, like, what sine of x looks like and how you should space out the radians on the x-axis, and like how far, like that the amplitude of sine of x and cosine of x, it just goes up to 1 and down to -1. So you'll want to label your scales, and then you're going to want to make those conjectures or guesses about the equations for each one, and spend some time checking your conjectures. Okay, for most of these, I'm hoping that you will be able to come up with the exact equation. All right, but if you can't, your graph should have the same basic shape as the graph of the difference quotients. All right, remember that's what the calculator is doing. It's setting up a bunch of difference quotients and then plotting those points to create the derivative. All right, and then once you go through all of that, you're going to look at the ones that, like, think about, see if you can guess any patterns. Okay, if you see any patterns in your guesses, can you make any generalizations? And you can write this out on your paper. You can type it up and include it with your pictures, but you're going to be submitting pictures of all this, and I need nice, clear pictures because this is a quiz grade. And so the quiz grade is really, did you take the time to put in the effort to make this neat and organized, and did you attempt every single one all the way back to x squared? Okay. So you're going to have, I need to see two graphs from, so the original and the derivative for x squared, x cubed, x to the fourth, 1 over x squared, sine of x, cosine of x, e to the x, and ln of x. So that's 9 sets of graphs, plus some sort of written, even if it's like a bulleted list of patterns you might have seen or generalizations you think you can make. And if you think there is some sort of pattern, take the time to see if it works for other similar functions. Test your conjectures and see if you're right. Okay, so I know that sounds like a lot, but remember, this is what we would be doing in a 2-hour block. So it may take you the better part of 2 hours, but I am looking for effort. These should be excellent quiz grades as long as you follow the directions and submit your work on time, and answer all the questions. Okay, so this is due Thursday by class time, 10:25. Remember, also on Thursday we will be finishing up the test so that we can get all the grades in for this 9 weeks. All right, I hope you are doing well, and I will see you on Thursday. Feel free to email me if you have any questions.